All right, welcome back, everybody. Joining us back from lunch. I hope you've all, managed to use the various facilities within this platform around talking to each other and having conversations and networking and doing all those useful things, but also found some time for, coffee and some edible sustenance. Now here we are back for another round of speakers, and getting us started on that will be Kyle from Jiffy Media, talking about circularity in CEA and growing media. So Kyle, over to you.
Yeah, thank you so much. Great to be here wherever you are. This is, I think, my third year I've been doing this, so it's a really great platform, great opportunity. Made a lot of nice connections through this virtual conference. So again, glad to be back this year. Bright and early morning for me, so we'll get started here. As my colleague mentioned, my name is Kyle Freedman. I'm the Global Segment Manager for Controlled Environment Ag at Jiffy Group, and also the product lead and manager for our new Jiffy Gel product. Jiffy is a growing media solutions company based in the Netherlands, and I'm going to be talking a bit about circularity and just efforts to improve that within our industry, specifically around growing media in CEA, and also what that means for new inputs, new products that can allow this sort of new era of on-farm production of growing media. I'm going to go ahead and turn my camera off just to make sure my internet stays pretty stable here. But we'll jump in a little bit with just giving some level playing field background on what is circularity. Sometimes we talk about this in terms of circular economy. These terms get thrown out, but often are a little bit confusing for people. In order to explain a little bit about what circularity is or circular economies, it's good to look at what a linear economy is, right? And that's pretty straightforward in the sense that most of our society is built off taking resources from our environment, using those to create different products, and then disposing of them. And again, that's a lot of how we interact with our world and how we operate as consumers on a daily basis. When we look at examples of that within our industry and growing media specifically, some peat extraction, depending on where you are in the world, fits that mold. Different mineral-based products that we use, plastic-based media or plastics in general, again, pulling resources from our environment, making something, disposing of them. But this idea of circular economy brings in sort of a whole new world of not just sustainability, but also becoming more efficient with what we're using, how we're using it before, during, and after use. And so there's different elements that we can start to look at incorporating as we become more innovative and find new inputs, new materials for growing media. So generally reducing what we are extracting from our environment. That could be the type of material, the amount, some element of reusing, recovery, as well as materials that might be regenerative. And obviously the golden ticket is to try and incorporate all of these, but I think, product evolution takes time. And I think being able to incorporate some elements of these is important. And if we look at conventional materials that have started to embark on this circular journey, cocoa core comes from a waste product, obviously sustainable in some senses, but maybe not others, bark or some wood materials, biochar, etc. These are examples of trying to incorporate some of these circular elements. Why is this important and why does it matter in CEA? It matters a big deal because CEA has really been leveraged for us to produce more plants more effectively, more efficiently in different parts of the world, and specifically for food. And as we know, agriculture makes up a huge part of our culture, our society. A lot of carbon emissions are generated from agriculture. And so if we can become more circular in such a big industry, we can have less of an impact on the environment, but also find ways to reduce costs, be more efficient. I've showed this before, but it's always good to just look at like how much growing media we're using for our world, whether that's ornamental use, food use, and where we're going. And so you can see here, historically in the past, like this is a general amount between different materials that we've needed to meet demand. And if you look at 2050, just how much more we have to produce. And a lot of that is obviously being driven by increase in population. But I do want to point out something that's easy to gloss over here is this new category at the bottom, right? So we have all these components that have been so common within our industry, Yet we have a category here of new materials that need to be introduced in order to essentially make the second largest volume of material after peat. Now, that won't necessarily be one material. It could be many materials, but it needs to be one or many materials that can provide such volume that we need. And so that's really critical as we look at the substrate industry and how that impacts CEA production. Substrates and sustainability are not new to many of us. There's a lot of materials that we've been fortunate to have historically and over time have found ways to become more efficient or realize that there's some shift we have to make in materials that we're using. Often that comes down to what we're extracting and how we're extracting that from our environment, and also elements of regeneration. And so that's really looking at fundamental entry point of just inputs that we're using and starting from that first step of circularity. Logistics, I'll talk quite a bit about this, but logistics are huge. We have sort of the blessing and curse of being a global economy where we can source materials from all over the world and have access to those. That's great, but that comes at the cost of long distances of shipping, both environmental cost as well as monetary cost just to pay for those things to get from point A to point B. And so thinking of ways that we might be able to reduce that footprint and both benefit economically as well as environmentally is important. One of the main messages I think I'll communicate and mention this a few times is just that circular products begin with smarter inputs. And so again, as we look at that new category that I showed, we're trying to find new materials that we can do more with. One way of doing that from a circular perspective is diverting waste or using byproducts from other industries, being smarter with how we can leverage those resources. Regenerative material is really important. So we can extract material from our environment to create new products, but how quickly are we able to regenerate those? And, think of peat moss or wood materials are great elements within our industry, but in some cases, depending on type of material, can take quite a bit of time to regenerate. And then generally, how can we do more with less, right? Less material to do the same thing would be great because there's a lot of benefits to using less. Resource efficiency is also a really important concept. That's mainly in production of the material itself, but also during its life cycle. An example of that is just, again, reduced transportation. And so I always harp on this just because it's sort of the silent killer sometimes with substrates and products is, we have availability of many different things, but getting them from point A to point B is expensive. So just being able to reduce that can create some more resource efficiency for us. Product performance is also really important. It's easy to think that, something like growing media in our industry, we can source something maybe more sustainable, less impact on our environment, and then maybe we jump straight to the end of life case where how do we dispose of it? But we also often don't think of circularity as during use. And I think it's really important that we start to shift our mind towards it's not just the front and back end of using a material that's important. It's also how can that create some efficiency during use for that full life cycle of that product. And so different ways that we can look at that is using products that could be more water efficient. Maybe they use less water, they hold more water. Also nutrient efficiency. So that's a big deal right now, especially with wars and geopolitics and things like that. As gas prices go up, fertilizer prices go up, and always trying to have a less impact on the amount of nutrients that we're using. And then also just, sheer plant development. Can we use materials that can increase root development, increase, biomass, time to harvest, things like that. That kind of production efficiency is important within thinking more from a circular mindset. End of life recovery, also critical. We always want to think of that. So there's been more of this shift in our industry to using materials that are fully bio-based, biodegradable, they can be composted, they can be reincorporated into soils or upcycled using materials that you can't do that, whether they're, plastic based or something that's just difficult to break down and incorporate, provides a lot of challenges, I think, for growers and for our industry, because we make a lot of that material, we consume a lot, and then we generate a lot of waste that really doesn't have a lot of use. So can we find more ways to use those waste products and reincorporate? Carbon and climate impact is really important. I'm not really going to talk too much about this, but again, just coming back to transportation and logistics, lots of carbon impact there on moving materials all over the world. But also, again, just the cost of the grower. So like, how do we make this more cost effective for people, whether that's sourcing local materials, using less of materials, having to ship less, et cetera. And I'll share an example of a product at the end to sort of bring all this together. Economic and supply chain resilience, that's sort of talking more about elements of business resilience. So not just the environmental side, but how can we be more able to reduce costs, to reduce waste, which also has a direct impact on cost. We always have to think about the business impacts as well, because that's critical for any manufacturer of a product, but even more so for the end user, which is our growers. And so being more resilient on the economic side is critical. So stabilizing supply chains, we're really struggling with that right now with, again, geopolitical issues, and that always comes and goes. So it's always a risk we have to deal with. We also would like to focus on reducing our dependence on scarce resources. There's a lot of resources out there that, even in their great abundance, climate, et cetera, can have a big impact. And so we want to identify other avenues for that. And that's where I think this topic of circularity being designed with the end in mind is a critical sort of thought to instill in you, that, we've often been given materials and we've made do with them and we've done the best we can with them and been effective, but we're not really designing those materials with that full circular mindset. And I think now we're seeing more emphasis on that. An example of this, I'm not going to focus too much on our product, but I will talk a little bit about Jiffy Gel, just being an example of this, so that you can tie all of these concepts together. But this is a new material, new product that we launched last year, really to be able to minimize the amount of material used, to use a more sustainable material, to increase some efficiency during production, which is critical, often overlooked, and then reducing the waste on the back end. And so how that actually works with a new input is, one, using material that comes as a powder. Obviously, there's not water content in there. We're not shipping water. We're shipping a lot less material. Being able to create a product on site that is using locally available water and creating a product that is mostly water creates a lot of efficiency, but it also just goes to show the sheer reduction in the amount of volume of material that would be needed for a grower to produce the same amount of plants with less. And then also just the minimal waste. So again, being able to go from a low volume, more sustainable input all the way to something that's going to result in a fraction of the waste that we would generate with other material. And that's really critical in CEA, because we're often producing plants and products that we are harvesting the biomass, and we are getting rid of the roots and the substrate. And so while substrate really helps us to be able to create great plants, we are generating more waste, and we have to be conscious of materials that are contributing to that, not just environmentally, but because, when you generate that much material, you have to dispose of that much material, and there is always a significant effort and cost associated with that. And so that's where sort of I'd like to culminate with this idea of on-site substrate manufacturing. Again, we are so used to bringing materials from all over together, creating value-added products and delivering that to customers. But how can we flip that and use less materials, be able to formulate those on site, keeping resources and materials within that facility, within that farm, and having less of an impact. And so there's different ways through an example like Jiffy Gel that we could do that. One, fully plant-based material. We're pulling materials to create this substrate from byproducts of other industries, often waste materials or biomass that's not being used from other products. Minimal bulk material again, so we're exponentially reducing the amount of material that we need to create the same finished amount of substrate. That has huge effects across the whole process, from production, from shipping, again, reducing freight to storage, all the way through the waste stream. Being more water efficient, again, I mentioned a product like this that's mostly composed of water can provide a lot of benefits depending on the production system of not needing as much water. Microgreens with this product are a great example because you don't even have to irrigate or use any added nutrients over the entire life cycle of that product, which is amazing. Reducing freight, talked a lot about this, more money in the pockets of growers, and then minimizing waste, again, reducing both that cost and environmental impact. And so building this framework, looking at new inputs that we have sources of, not just, again, to be more sustainable, because often that's nice to have and we want to be more sustainable, but if it's not saving costs or somebody's not willing to pay more, that's a challenge that everybody has to face. And so the objective is really to be more circular, more sustainable, by reducing costs somewhere along the chain and making that more effective. So I'm at time. I will finish there, give some time for questions. Again, my email is up here. If you have any questions and you want to email me directly, I would love that. You can reach out to me on LinkedIn, and then also utilize the Pine platform to message with me directly. So we'll jump into Q&A here.
Brilliant, thanks, Kyle. That's really interesting stuff, actually. Love the sort of circular economy thing. I want to just pick up on a point here. You mentioned resilience and supply chains, and it's really good that you talked about that, obviously, in terms of the sort of economic considerations and the environmental considerations, but you did also mention, the kind of systemic risks and vulnerabilities right now. I mean, how critical are they right now? How important do you think that is, and how much at risk are the kind of supply chains that things like substrates rely on?
Yeah, it's a huge risk. I mean, again, we were sort of grateful to be able to have resources where we could create different products globally, but it takes a lot of effort to get those to our growers, to manufacturing facilities. And we kind of have a lot of risk on multiple ends. We've seen the climate risks over the past couple of years. That's impacted, peat harvest, that's impacted cocoa. And so, again, being able to use less material, more local material, et cetera, can help mitigate that. But yeah, the war is going on right now in the Middle East and things like that. When trade routes get blocked, there's not a whole lot you could do. It's either going to take more time, it's going to be more expensive, or something's just, not going to show up. And growers, especially in CEA operations, operate 365 days a year. There's no room for error of having material not show up, because then you can't produce. And so if we can create materials that, maybe can be purchased one time, stored for the year, you don't have to have like recurring orders and things like that. If geopolitical issues or climate, whatever, pop up, it's not really a problem. You're good to go, or you have enough to sustain you for a long time and can do more with less. So I think that's really critical. And we're seeing some repercussions of that now, maybe more on cost increases because fuel's going up, shipping time, et cetera. So it's critical. And I think we've historically seen that come and go. So
Nice. A couple of questions from the audience here. Do you have any thoughts on cleanliness of product, taking pests, bacteria, and potential production risks in a closed CEA environment into consideration?
Yeah, I guess from a couple different perspectives. One, good IPM is always important for a grower, and it's impossible to completely mitigate risks. I think, again, when it comes back to circularity and building, and designing growing media with the end in mind, that is something that has to be taken into account when creating new products, because, we provide a lot of organic materials, and those products are great and will continue to be used, but some cases can come with some risk. And so there's always that balance of like trying to be extremely sterile with media or things that you use in your environment, which is, really impossible, but trying to start clean and keep things clean is also important. So again, with the example of Jiffy gel coming as a powder, it doesn't have that risk. And then also during production on site, there's a step that would eliminate that risk as well through heating. And so those are elements that have been built in to be able to mitigate those risks and control, pathogen, control cleanliness, etc. So I think that's critical. A lot of ways to do that, but it's no substitute for good growers, good operations that have good IPM, because we can build the fanciest farms in the world, and pests, disease, etc. are always going to find their way in. So you got to be prepared for that no matter what.
Yeah, I mean, fair point. Following a not entirely dissimilar line, another question from the audience here: how would you control for quality when using waste plant materials on site? Is there a risk of accumulation of biocontaminants or salts, for example, and how would you mitigate for this?
Yeah, that's a good question. I think depends on the material you're using. I think a lot of plant biomass residue, et cetera, is not necessarily going to come with that salt risk like we see with coco coir and things like that. I think working with good suppliers is critical, like knowing your material, where it comes from, having controls in place in sourcing. Obviously, just sourcing material that you don't know a lot about opens up a lot of doors for some issues. But I think during processing, during manufacturing of those materials, there's many ways to create consistency and uniformity, and that's a critical element for us as a manufacturer, and also to keep that in mind when providing material to growers. So it all starts with knowing the inputs, the sources, how you're formulating products, designing those products.
Right. Yeah, fair answer. One last question, I guess the critical question, of course, is because whenever we talk about these kind of things around, environmental impact or new products that deliver some circularity benefit or whatever it is, the question that every grower presumably is going to have at some point is, will it still deliver the same results? Will it still deliver the same benefits? Like peat, for example, has stayed around for as long as it does because it does certain things very well, right? Can these newer materials match that performance?
Yeah, it's a great question. I mean, no matter where you are in the world, peat is one of the best materials to grow plants in. Like, it just has all of the characteristics. It's resilient. It's effective. We can't create new materials that are just going to be sustainable and don't match on performance. And that match on performance might be system specific. It might be crop specific. It might be, everything works just equally as well. And I think if you can't deliver on that, it doesn't make sense necessarily just to be more sustainable, right? Because then we're going to have downstream issues in production. We're going to produce less. We're going to use more resources to try and get performance up, and then we're just breaking that circularity cycle. And so I think it's critical that, number one, first and foremost, I would say we need to make sure performance is there, whatever those performance indicators might be, and then those sustainable components come in. I think we all want to be more sustainable for the sake of being sustainable, but as I mentioned, there has to be performance benefits during use of that product. As I talked about a little bit, like, you can't neglect the critical element of, like, how is it performing for you? It could be better on the front end, better on the back end, but that's, all good and well, but it's not completing the picture. And so making sure performance is there. And then after that, then those other benefits can sort of multiply themselves and really create a complete solution that can solve some other challenges. And that's what we're looking for.
Brilliant. All right. Well, thank you so much, Carl. That's I really appreciate the honesty of that answer as well. I think it's really important to have that. But thank you so much for joining us today, for answering the questions. If you want to reach out to Kyle, if you want to know more about circularity and sustainable substrate solutions, find him on the platform, find him on LinkedIn, as he said, or through his email there on that slide. Kyle, thank you again, and we'll be back momentarily with our next speaker.
Yeah, thank you so much. Take care.